Well, hello guys and welcome back to Mr. G Physics, the channel that can help you to improve your marks. I'm Mr. G and this time we're going to be working about or speaking about force diagram. This one is for the grade 11, however applicable for the grade 12 as well. If you're new in the channel, don't forget to subscribe so you can get the notification on videos I post on regular basis. Let's start by defining force diagram. So, what is a force diagram? A force diagram is a sketch. It's going to be in a sketch of the physical situation you are dealing with arrows for all the forces drawn on the system. So, in this sketches of force diagram, we're going to represent the object that we're dealing with, and on the object we're going to represent all the forces acting on that object using arrows. Now, there are a few things to keep in mind before we start going into details. There are a few things you have to keep in mind. The first one, the drawing must be large and clear. Second, you will represent the forces with vectors. So you will use forces to represent vectors. Third, all forces must have label. For example, Fg, or could be the W. We also did the normal. We also did frictional force. Let's try, for instance, Fk. So these are some examples of labels you are going to use, guys. If the force doesn't have labels, you will lose the mark. It's wrong. Fourth, identify correctly all the forces acting on the object. And this is the most important thing. There's more details you will learn eventually, but this is the main thing you need to have in mind. So, saying that, let's see some examples. Let's look at some scenarios. Alright, so this scenario is an object which is at rest on a horizontal plane. What forces are acting there, guys? Only the force of gravity weight due to the earth. That force will start from the center of the block, pointing straight down. Okay? This one here is weight. You write gravitational force is also correct. And then we also have the force that the surface exerts on the object. It's going to be from here all the way straight up. This one is normal force, also known. And there is no friction because the object is not moving and is not trying to move. This second scenario is an object moving under the influence of a pulling force horizontal to the surface. And the first part of this one is the same. We have the object, there is the normal force, there is the weight. What is the difference in this case? Now we have an applying force or pulling force. Let's draw it to the right, for instance. And that force is horizontal to the surface. So it's a pulling force. I'm going to do it in that direction. And this one is, let's fix that head. That is a pulling force. I'm going to call it applied force, the force that somebody is applying on that object. And then because there is a pulling force to the right and the object is moving to the right, there is also frictional force. In this case will be kinetic frictional force. There is the kinetic frictional force pointing to the back. There we go. This one here is kinetic frictional force because the object is moving. These ones are the first two scenarios. Now, this scenario is similar to the second. The object is moving under the influence of a pulling force that makes an angle to the 30 degree with the horizontal. So it's moving, it's on a horizontal surface, but the force now makes an angle of 30 degree with the horizontal. So let's do that. This force that is pulling the object to the right is not straight parallel to the surface. Instead, it makes an angle of 30 degree. So this one is the applied force. Alright, that one is the applied force. So in this case, just for you to get the idea, this here would be the horizontal parallel line to the surface. Okay, this object or this applying force, in other words, is making an angle of 30 degree to the horizontal. You see, it's not parallel to the surface. And then still the frictional force, we're going to represent now the kinetic frictional force. There is the kinetic frictional force pointing to the back. This one is kinetic frictional force. And then let's look at one last scenario. Or let's say, for instance, two more scenarios. And in this case, the first or the fourth scenario is the object that is going to be resting on an inclined plane. Now, this one is slightly more tricky. Alright, so this is the situation. This object is not moving and is on the inclined plane. The plane make an angle. Okay, so this is loop. Now here in this case, this plane, because it's inclined, will have theta here. We have an angle of inclination. Okay, so now what forces are on that acting on that object? First of all, weight. Weight is always pointing down towards the center of the, so from the center of the object straight down, all the way down, this one is weight or gravitational force. Either one you can write, it's up to you. The surface is acting on the object with the normal force. Normal force always perpendicular to the surface. So in this case, normal force will be a straight line in that direction. I just want to move it a little bit to the, maybe there is fine. And then that will be the normal force perpendicular to the surface. Be careful with that one. That's why I say this one is tricky. If you look carefully, this one is or must be perpendicular there to that surface. Okay, so that's it. And now this object is not moving, but it's trying to move down the slide. It is trying to slide down. It doesn't do it because there is frictional force, which in this case is going to be the maximum static frictional force. I just want to write this one must be parallel. Let's try to fix that line there. Must be parallel. There is the one, and this one here is the static frictional force. Guys, those are the three forces acting. This one is the one that could be a little bit tricky. You know what? Let's move it a little bit down so you don't get confused with the other one. There is much more clear. Okay, so that is the third scenario. Let's go to another one, last scenario of all. Okay, and this is the same object, but the object is going to be sliding up the incline. Now you would ask, how is the object sliding up? Well, somebody kicked the box. Let's say somebody kicked the box up the incline, and the box move it up a little bit. It's not going to move forever, you know, it will stop, but it will move up a little bit. So what is the situation here? It's the same as before. The only difference is that this object is moving in that direction. It's moving in that direction, and we must have that in mind because that one will change the direction of the frictional force. I'm doing this one because I've seen a lot of problems. So let's say this object is going to be down. That is first of all, that is the weight of the object. Okay, this one is weight of the object. You can write gravitational force, and let's move it a little bit more to the center. There we go. That one is much better. Now we have the normal parallel to perpendicular to the surface, so it's going to be in this direction. Make sure it make an angle. That one is the normal force. Let's also just move it a little bit to the right. There we go. And then this one is the normal force, and then it's friction, but the object is moving up. The object is moving up, therefore friction is pointing in the opposite direction of motion, and saying that will be pointing down the slope, the slide in this direction. That will be the frictional force, and in this case is kinetic frictional force because the object is moving. Now, important mistakes that learners attempt to place here, they attempt to place a force acting up. There is not applying force. The object was kicked up or pushed up, and then it moved a little bit. There is something you're going to learn a little bit later. And guys, this is some examples. I cannot represent all the possible examples, but I think these are the ones that can make you confused. I hope it helped. If it helped, thumb up, subscribe for the channel, the right messages, and I'll see you next time. Next time we're going to be speaking about free body diagram. I'll see you next time, Mr. G here.